This is the tutorial for the Hierarchical Independent Component Analysis Toolbox, or HINT. This toolbox can be downloaded from the CBIS GitHub page, and I will provide a link to that in the description of this video. So, the toolbox itself consists of three panels. The first panel is the Prepare Analysis panel, and this is where you will select an output folder for the analysis, read in the data, specify your model, and generate a set of initial guesses for the EM algorithm. The second panel is the Run Analysis panel, and this is where we actually will run the expectation maximization algorithm that estimates the parameters of the HC-ICA model. And then finally, we have the Visualize panel, and this is where we will view our results and test hypotheses about the covariate effects. So let's get started. So we'll go to the first panel, which is the Prepare Analysis panel. And in the first subpanel, there are two things for us to select. The first is the Analysis folder. So this is the folder where all the output for the analysis is going to be written. So I've created a file on my desktop for that called Tutorial, and I will just select that. And then the second option is to create a session log. So if we check this box, HINT will write some basic information about the analysis that we've carried out to the folder that we just selected. So this can be useful for going back at a later date and figuring out exactly what it was you did in an analysis. The second subpanel, Input, is where we are going to read in our Nifty files, read in our covariates, and select a gray matter mask for the analysis. There's actually two options here. The first one, Import Nifty Data, I'll come back to in a second. But the second one, Load Saved Analysis, is for if you've already done a HINT analysis and you want to come back at a later date and either repeat some of the work you did or change something slightly about the model, then you can use this Load Saved Analysis option to load your previous results and avoid starting fresh from the beginning. But since this is a new analysis, we're going to use the Import Nifty Data option. So we'll select that under Input Method, and then come down here and press Load Data. After clicking on Load Data, we're presented with three options, three blanks to fill in. So the first blank, Load Subject Data, is where we are going to put all the individual Nifty files for the analysis. So these are the subject-specific data files. Once we click on Browse.nii files, the HINT toolbox is going to ask us if our data are all contained in the same folder. We present this option because some pre-processing streams will write each subject's data to a separate folder, and in those cases you can press No, and the toolbox will do some pattern matching for you, and that way you can avoid having to specify each of the file locations individually. But since our data are all in the same folder, we'll just press Yes. And this file selection window will open. So my data is contained on my desktop, so I'm going to go there. And it is within the Study Data folder. So once you navigate to your data, all you have to do is select all of it and press Add and Done. And we see that the form here is filled out with the file paths to each of the data files. The second thing we need to do is specify a mask for the analysis. So this is a gray matter mask just to help keep the amount of work that the EM algorithm has to do as low as possible, so we can avoid doing work in the white matter areas and the CSF. So again, I've placed that mask in the same folder. So I'm just going to come over here to Study Data and select this gray matter mask. And then finally, we need to load a covariate file. So before I load that, I'm going to show you what the general structure of that file should look like. So I've got it pulled up here. The first column of this file should have each of the file names in it for each subject in your data set. And we do this so that when the toolbox reads in each of the files, we can match them up to the appropriate row of the design matrix. So if you look at each of these RS2MM files, you see that this matches up with the subject files that we loaded in a minute ago. And then the first row has the word file. So this is just to help the toolbox know which column it should be looking at. The remaining columns are essentially the design matrix. So we have in the first row the name of each of the covariates, and then in the remaining rows we have the settings for each subject. So for example, we can see our first column corresponds to our first covariate, which is the treatment group. And the first half of the subjects are in the treatment group, and the second half of the subjects are in the control group. So I'm just going to go ahead and specify that CSV file, which I've got saved in the same location. And then I'm going to click on OK. And this is going to load the data. I'm going to pause the video while that loads. Okay, so now that our data has finished loading, we're ready to specify the covariates for the model and then move into pre-processing and forming an initial guess for the EM algorithm. So first, to do our model specification, we'll come over here and we'll press on Select Covariates. This opens up the model specification window, which lets us view and change different things about the model. So at the top of the window, there's a box where we can view the design matrix. So the first column of this box has the subject name in it, and then the remainder of the box is the design matrix. So we can check that the data loaded in correctly and that it has been coded how we want it to be coded. For example, we can see that the first column here has been reference cell coded. It no longer says treatment or control, it's zeros and ones. And we can see that the reference group is the control group. The first subpanel here lets us pick what covariates are included in the model. So by default, Hint is going to include all of the covariates in your covariate CSV file in the model, but you might have some extra covariates in that file that you don't actually want to fit the model to. So for example, say that we had included normalized age in the model, but we didn't actually want to include it for the HCICA modeling. We could select it here and click on Remove, and we would see that it would be removed from the design matrix and removed from the analysis. However, for this example, we do want to include age, so I'll select it and I'll add it back in. Second, we have the ability to specify the type of each covariate. By default, Hint is going to read in string and character variables as discrete factors or categorical covariates, and anything that is numeric as a continuous covariate. However, a lot of the time you might code some variables that are categorical as integer values, so maybe 0, 1, 2, 3. In that case, you would want to switch it over to be treated as categorical. So in this example, we have gender, which is coded as 0 and 1, and by default, Hint has read it in to be a continuous variable, but we want it to be a categorical variable. So I'll select gender, and I'll click Make Categorical, and we'll see that it has moved over to the categorical box, and in our design matrix, we now have a reference cell coded version of it. So we can see that gender equals 0 is the reference group, and gender equals 1 is the non-reference group. If for some reason we wanted to change the reference group, we can do that down here in the Specify Reference Category box. So I could select the covariate gender, and I could change the reference category to 1, and we would see up here that now the reference category has been changed to 1. And then finally, the last set of panels here allows us to add interaction terms to the model. So for example, if I wanted the interaction between group and age, I could select those two from the drop-down menu and press Add Interaction. We'll see that that interaction will appear in the interaction list and in the design matrix. However, for this experiment, we don't want to include any interactions, so I'm going to remove that, and then I'm going to close out the box. Once that's taken care of, it's time to pre-process the data and obtain an initial guess. To do this, there's two boxes that we need to fill out. The first is the number of principal components, and the second is the number of independent components. So for this experiment, we're going to use 40 principal components and 14 independent components. And this is something that you can kind of tweak as needed if you feel like more components are needed or fewer components are needed. And then once we've done that, we're going to select PCA dimension reduction, which is going to pre-whiten and pre-process the data for the HCICA analysis. So I'm just going to click on that. And this will take a minute or two to run on this data. So I'm going to pause the recording and I will come back when it's finished. So now that we've finished pre-processing the data, the next step is to obtain an initial guess for the HCICA model parameters. We're going to do this using the GIF toolbox to perform temporal concatenation group ICA. So in short, this is where the number of PCs that we've selected comes into play. So as a first step, each subject's data is going to be reduced down to, in our case, 40 principal components. And then the GIF toolbox will perform a few more steps of dimensionality reduction, and then following that we'll be able to get our initial guess. So I'm going to go ahead and click on this button to start that process, and then I'm going to pause the video until that finishes, and then we'll be able to look at our initial guesses. Okay, so once the initial guess finishes running, the hint toolbox will automatically open up a result viewer that will let you view the results of your initial guess. So the hint result viewer looks about the same across different viewing items. So for example, here we're viewing the initial guess, but later we'll be able to use this same window to view the covariate effects and the population aggregate maps, along with subpopulations and single subject maps. We'll be talking about that more later, but for now, all that you really need to worry about is this main viewing window, which lets you see the estimated independent components overlaid on a brain, and then this IC selection box right here. So this box keeps track of the different independent components that are going to be included in the HCICA analysis. By default, all of them are selected, which you can see by these X's in this column here. But if for some reason you look through the components and you decide that one of the components you're not really interested in, or you don't want to include it in the analysis, you can select that component from the drop-down menu here, and then uncheck this Use IC box. So for this example, we had switched to the third IC, and we unchecked the box, and we see that there's no longer a little X mark by IC3 in the IC selection window. But for this case, and for most cases in general, we recommend just using all of the independent components that you obtained an initial guess for. So I'm going to reselect this, and we'll see that the X comes back in, and then I'll hit close. So at this point, we're ready to move on and use the EM algorithm to actually estimate the model parameters. So I'm going to click on Save, Setup, and Continue, and the toolbox is going to ask me to select a prefix for the analysis. So this is going to create a subfolder within our analysis folder that we specified, and all of our output is going to be written to this subfolder. So I'm just going to go ahead and call this, I'll call it 1, because this is the first analysis we've run in this subfolder, and then click OK. And this is going to save something called the run info file, which we can use to replicate our results at a later date using the load saved analysis button, as we talked about earlier. We're also going to use it when we load our visualization results later, basically as bookkeeping to help us keep track of what we're looking at. So I'm gonna open up the data results real fast, and we can see that there is now a folder in our tutorial file called One Results. And if I go into that, for now, all we have is the run info file and a copy of the text log. So I'm going to close that out, and now we are ready for the EM algorithm. So the run analysis panel doesn't actually have a lot that you have to specify, just these 3 tuning parameters for the EM algorithm. The first one, the maximum number of iterations, is the maximum number of iterations that the EM algorithm will run. And then the second 2 are convergence criteria. So these measure how much the EM algorithm changes from iteration to iteration, and if it falls below these specified thresholds, then the algorithm will terminate early. Otherwise, it'll terminate when it hits the maximum number of iterations. So there's 2 of these parameters. The first one, corresponding to the global parameter, measures changes in all the parameter estimates except for the covariate effects. And then the second one, the local parameter, measures the changes in the covariate effects. So once the changes fall below both of these epsilon terms, the algorithm will terminate early. So I'm going to go ahead and hit run, and then pause the video because this will take a little while to run, and then I'll come back when it's completed. And now we can see that the algorithm has finished running. So the progress bar is at 100%, and we can see that the global parameter converged fairly quickly, but that it took the local parameter, which corresponds to the covariate effects, quite a bit longer to settle down. And that's pretty common with this approach. So now that the algorithm is done running, we can visualize our results, which we can do by pressing the Display Results button. Now, if we were viewing these results for the first time after opening the toolbox without running the analysis, we would need to specify a display path and a prefix, which would basically just point to the run info file that I showed you earlier. But since we just ran the EM algorithm, those things are already loaded, and we can move directly to examining our results. So the first viewer we're going to look at is the Population Display Map Viewer. So I'll just select that and come and click on Display. And we'll see a similar window opens up to what we were looking at earlier when we were choosing ICs for the analysis. So this viewer is the Population Average Viewer, and it's just the average of the estimated independent components for each subject. So it gives us a good idea of sort of what the overall appearance of our independent components is. So, for example, we can click around on the brain, and there's a few things that are worth noting about this viewer and all the viewers. So all the viewers have this location and crosshair information box. So this box gives some information about the area of the brain that the crosshair is located in, tells us what the position is in terms of the dimensions of the original image, and then also it shows us the value at the crosshair. So for example, the current place that we have selected in the brain has a z-score of 3.24. In this panel over here, we can decide which IC we're looking at, and we can also apply masks to the image. So I can change from IC1 to IC2, and we can see that the brains have changed in response to that. And we can do thresholding using this Z thresholding bar. So for example, in this image here, we can see that the front of the brain is quite active, but maybe not so much the rest of the brain. So we can threshold this using the slider, and I'm actually just going to type a threshold in. And we can see that we've now reduced the brain just to the areas that are showing a significant amount of activation. One thing we can do here is we can create a mask using the Create Mask button. So what this will do is this will create a mask in the output folder based on your current thresholding level for the currently selected IC. So I'm going to press Create Mask. It's going to make the mask for us. And now, if I come over here to the Mask Selection drop-down menu, we can see that the mask we just created has showed up. So if I get rid of the Z thresholding and I reduce the map back to its original appearance, I can come over here and I can select the mask from the drop-down menu. And we can see that it has applied that mask to the image. So that's about it for the Population Average Viewer. Next, we're going to look at the Subpopulation Viewer. So I could close this out and select it back from the original visualization panel, but there's also just a drop-down menu we can use to switch viewers. So I'm going to switch to the Subpopulation Viewer. At first, nothing's going to be plotted because we haven't specified any subpopulations yet. So what this viewer lets us do is it lets us look at the estimated brain map for people with a certain set of covariate values. And we do all of the control and specification of that from the subpopulation control panel. So for example, let's say I wanted to see the estimated brain map for a person who is in the treatment group. So we would specify 1. And for their normalized age, let's do 0.5. And then finally, we'll say that they are gender 1. So that would be a 0 under this coding scheme. Now that we've completely filled out the subpopulation, we can see that the display window has updated to show us the estimated maps for this subpopulation. And we can see that these look kind of similar to the maps we were looking at before for the first independent component. Now, one thing that might be of interest is comparing two subpopulations. So I could add another subpopulation. Maybe this time we'll say that they're not the treatment group, and we'll give them the same age and the same gender. Now, we'll see that we could view this subpopulation from the subpopulation control panel by switching to it. But we can also compare the two by coming down here and pressing on Compare Subpopulations. This will open up a subpopulation selection window. Since we've only created two, we'll just select the two that we've created, and we'll click on Compare Selected Subpopulations. This will open up a new window that lets us view the two subpopulations side by side. So we can see that our subpopulation number 1 is here, which is the subpopulation that is in the treatment group, and our subpopulation 2 is on the right, which is the subpopulation that is not in the treatment group. And we can see there's some differences in this area, and as you see when I click, the crosshairs are synchronized so that they go to the same place in both images. So this can be useful if you want to compare two different sets of subpopulations and get an idea of where the differences in the brain are. When we're done with that, we can come down here and press the Close Window button to revert back to the original display window. And that's about it for the subpopulation control panel. I'll also mention that we can apply that mask we created earlier to this panel. So I believe that mask was to the second IC, and we can see that the mask is right here. So if I click on that, we see that reduced area of the brain. The third display panel is the single subject display panel. So this will always take a moment to load because we generate the subject specific maps on the fly as you select them. And this is to keep down on the total amount of space we use. Because if you have a large number of subjects and a large number of independent components, that can quickly eat up quite a bit of your memory. So this just basically lets us look at the independent components for each individual subject. There's no real special functionality here. We can wait for a second for that subpopulation to form. For that independent component to be generated. And we can apply masks to this image, just like before. It's useful largely as a sanity check to make sure that your subject level maps are coming out correctly. And then finally, and most importantly, is the covariate effect window. So this lets us view the estimated covariate effects on each of the independent components. So this is the main thing that we're usually interested in an HC-ICA analysis. For example, right now we're looking at the effect of being in the treatment group on the first independent component. We can do a similar thing by selecting normalized age. We can see the effect of age on the first independent component. And then finally, we can select gender and see the effect of gender. One thing that's worth noting is that for this window, we're using model-based standard error estimates to do the z-thresholding. And that means that any thresholding we do corresponds to valid hypothesis tests on the covariate effects. So for example, I can see what is significant at a z-threshold of 1.96 by putting it into this box and selecting enter. And we can see that there's a few regions of the brain that are showing significant treatment effects here. Another feature of this window is that we can use it to test contrasts about the covariate effects. So much in a similar way as to the subpopulation window, we can come to this covariate contrast box and we can add new contrasts and fill them out. So for example, I can test which areas of the brain are significant for a treatment group of 1, say a normalized age of 0.7, and a gender of 0. So that's going to create this contrast, C1. But we can see in the information box right now, we're not looking at that yet. We're currently looking at the covariate effect of group equals treatment. So I can select this from the drop-down menu, click on C1, and it'll change to the effect of the specified contrast. And then we can see the regions of the brain that are significantly altered by this contrast. So that's about it for the hint toolbox. There's also a user guide available on the GitHub repository that has a little more information than this video had. And if you run into any issues or have any questions, feel free to leave a comment on the GitHub repository.